In this video, we will cover other problems from our exam, second exam. The first one is to find our matrix. By doing this, we have to put A and B into a matrix. To find this first, we have to know our homogeneous linear system. There will be -3, 2, -1, 0, -2, -2, x, y, z equals 0. So next we have to find our matrix by Gauss-Jordan elimination. By doing this, we have to subtract R1 minus R2. That will lead us to -3. One, 2, 2, 2. -3. So once we have this, we have to put all our first zero of our row of our diagonal. So our first row is have to be divided by -3. All the row -3, and the second row have to be divided by -2. By doing this, we will know that our matrix is 1, 0, 1, 0, 0, 1, 1, 0. So this could tell us that x plus z is 0, and y plus z is 0. So in this case, we could tell that x is equal to -t, y is equals to -t, and z is equals to t. By moving our c minus, it will be x minus c and y minus c. That's why we substitute our c variable, leaving that c is equals to c. In our second problem, we have to find the parallel pipe size volume. So we have to put u, b, and w into a matrix. So in this case, it will be 2, 0, 2, -6, 4, 2, 2, -2, -4. Once we have this, we have to find our determinant. In this case, we'll do something like getting our first value. So in this case, we will take that 2 value. So we will just wrap it here. Ignore our rows and columns that are behind them, and then start our formula. So we can tell that it will be 2 times 4, 2, 2 plus 4. Then we go to our 6 and we say -6, 0, 2, 2, -4, and then finally plus 2 times 0, 4, 2, 2. So in this case, in this cross product, we have to multiply 4 this, and then multiply this minus the. We have to multiply this by this value, and this subtracted by this times this value. So in this case, it will be 4 times -4 minus 2 times -2, and all this is times 2. So in this case, it will be -16 -4. This will be plus -12. 12 times 2 is -24. Minus plus -6, this will be +6. So we just have to do this with our cross product. So in this case, our result will be 16. And we have to do the same thing with our next vectors at u, v, and w to put it into a matrix. So the matrix will be something like this: 3, 4, 1, 1, 5, 2, 2, 1, and 4. Exactly the same method as the other one. So we just took our row, whatever we want. So in this case we get a 3. We ignore these values and just get times our values that are not behind our select value. So like 3 times 0, 2, 1, 4. Then minus this and this, and then this and this. So you get the point. So in this case it will be 45, the answer, in our parallel pipe volumes. So our last problems, we have to find our scalar moment of F, that is the force, and the direction angles of F, that our force is 1000 newtons. This is our graph. We know that our range is 1 meter and our latitude is about 2 meters. So telling that, we have to follow our formula, knowing our positions. So in this case our positions will be is this. How we find these positions? By doing a Gauss-Jordan elimination, putting that is 500 squared u 1 0 0 u 1 1. So in this case we know that is minus 2 minus 1 minus 2. Our point set in this times 500 squared u. So to find the magnitude, we just have to do our cosine rule, that in this case is cosine minus 1 into our angles. In this case our angle will be 1000 squared u divided by 1500 squared u, knowing that this is 132 degree. So we have to find that for our three angles. So find by yourself, but it will be this 129 degrees and 132 degrees. So this is our final solution for our final question of our exam. So I hope you enjoyed the video.